Hello everyone, my name is Ibukunolu Ademola. I'm here again to teach you balancing of simple ionic equation. Trust me, you are going to enjoy today's lesson again as usual. You are all welcome on board. Thank you. Our topic for today is balancing of simple ionic equation. My name is Ibukunolu Ademola. So what are we here to learn today? Today, we are going to first of all look at how to balance simple ionic equation. We are also going to talk about half reaction, and we also move on to how to break an ionic equation into half cells. And lastly, we also look at the differences between oxidation half and reduction half. How do you balance simple ionic equation, or how do you balance an ionic equation? So these are the first four things that you need to do each time you want to balance an ionic equation. The first is you should always ensure that the number of atoms of each element on both sides of the equation are equal. So the number of, let's say, hydrogen at reactant side and hydrogen at the product side must be the same. So if you're having two hydrogen atoms at the product side, you must have two hydrogen atoms at the reactant side. And the second thing is that the number of positive or negative charges on both sides must be the same. So if you have 4 positive charges at the reactant side, you must also have 4 positive charges at the product side. They must be the same thing. The third thing you need to know is that the total number of positive and negative charges on each side of the equation must add to 0. So what it means is that when you add the positive and the negative side together, you must get 0. You must get 0 in your equation. You get to understand that when we get to the balancing of equation. And the fourth thing you need to know is that in the overall equation, the ions that are appearing as reactants and also appear as products must cancel each other out. So which means that if you have 4 molecules of water at the product side and you have 4 molecules of water at the reactant side, such will cancel each other out. But if it is ion, if you have 4 moles of electron or 4 ions, let's say 4 moles of sodium ion at the product side, 4 moles of hydrogen sodium ion at the reactant side, since they are equal, they cancelled each other out. Now let's quickly look at half reactions. When a redox reaction is separated into oxidation and product parts and reduction part, I beg your pardon, each constitutes a half reaction. So breaking an ionic equation or redox reaction into 2 halves, that is oxidation and reduction parts. That oxidation reaction and reduction reaction represents half reactions because the two of them are removed from a single ionic equation. So when you have oxidation reaction, that is half reaction. Reduction reaction is another half reaction. So the two of them put together will make a single redox reaction. So the separate equation then show the half reaction and show oxidation half and reduction half. So if you look at this equation that we have here, if you look at this, you will discover that we have copper and 4 moles of triazonitrate 5 acid. But here, the oxidation number of copper is 0. But at the end of the day, hydrogen that is in the triazonitrate 5 acid have been removed, which is one of the features of the number of oxygen atom here rather decreases from 3 times 4 12 to 2 times 4 8. Now a removal or decrease in the number of oxygen atom is one of the characteristics of a reduction reaction. So for the number of oxygen atoms present in triazonitrile acid at the reactant site to have reduced here where we have nitrogen 4 oxide shows that a reduction reaction has taken place because the number of oxygen atom decreases from 12 to 8. And here we have only the copper at the reactant site. At the end of the day, we have oxygen added to it. Now, when oxygen is added to a substance that does not contain oxygen, or when the number of oxygen atoms in a particular substance increases, oxidation reaction are taking place. So here we have only copper, but here we have oxygen attached to it. And because there is oxygen added to it, we say that an oxidation reaction had occurred. So copper forming copper triazonitrate 5 is an oxidation reaction, and triazonitrate 5 acid reduces to nitrogen 4 oxide, shows that a reduction reaction had taken place. So this single redox reaction have been broken into two, into oxidation half and reduction half, as you can see in the equation here. So now when you now talk about half reaction, what are the steps that you must follow when you are balancing redox reaction using half equation method? The first is you break that equation into half equation, that is into half oxidation half and reduction half. So by the time you must have done that, but before you do that, you must have the idea what are the characteristics of oxidation reaction, what are the characteristics of reduction reaction. Those are the things you use to break that equation into oxidation half and reduction half. After you have done that, the second thing you need to do is to balance the atoms in each cell except oxygen and hydrogen. So you can balance every other atoms, but you don't balance oxygen and hydrogen in the two half cells. And the third thing you need to do is to now determine the oxidation number of the atoms on the reactant side and on the product side. So you calculate the oxidation number of those atoms at the product side and at the reactant side. Don't forget, do not touch oxygen and hydrogen. After you must have done that, then you move to the fourth stage. What is the fourth stage? The fourth stage is that you will calculate the difference in oxidation number to determine the number of electrons. So you see what is the oxidation number of this particular atom at the product side, what is the oxidation number at the reactant side. Look for the difference in oxidation number, and that will tell you the number of electrons that is gained or that is lost. You will get to understand that when we get to the next slide. So the next step, which is in step number 5, now is to balance the electrons on both the oxidation half and the reduction half by multiplying with an appropriate coefficient. So you ensure that the number of moles of electron at the oxidation half and the number of moles of electron at the reduction half are equal. When they are not equal, you multiply by using an appropriate coefficient. So the number of electron gain and number of electron loss must be equal. You will get to know how to do that in the next slide. And the last thing you do after you have scaled through the first step, second, third, fourth, fifth, then the last is to add the two half reactions like in simultaneous equation. So you add them together at the end of the day. So let us look at this example number 1. The chemical equation we have to balance is this: sodium plus hydrogen ion, the two of them react together to form sodium ion and hydrogen gas. So if you look at this very well, since the first thing is to break this equation into half cells. So this is sodium forming sodium ion, and this is hydrogen ion liberating hydrogen gas. So if you look at this, when an atom is in free state, the oxidation number of such atom is 0. So oxidation number of sodium here is 0. But oxidation number of sodium ion, which is the product now, is +1. So there is increase in oxidation number of sodium from 0 to +1, which shows that oxidation reaction had taken place, because oxidation is increase in oxidation number. And that is why sodium is posted to the oxidation reaction side. So that's why we have sodium form sodium ion, sodium metal form sodium ion. And on the other hand, the oxidation number of hydrogen here is +1, H+. And at the end of the day, this hydrogen ion liberated hydrogen gas. The oxidation number of hydrogen gas is 0 because it is in free state. And for the oxygen number to have decreases from +1 to 0 shows that reduction reaction had occurred. So what do? We put H+ form hydrogen gas at the reduction side. So what is the next thing to do here? Since we have 1 mole of sodium metal, 1 mole of sodium ion, there is nothing to balance. But in this case, we have 1 mole of hydrogen ion, but we have 2 atoms of hydrogen. So we can see that this is not balanced. What do? Since there is discrepancy in the number of hydrogen at the product side here and the reactant side. So to balance this, we put 2 in front of hydrogen ion. So we now have 2 moles of hydrogen ion liberating 1 mole of hydrogen gas. So we have 2 atoms of hydrogen at the product and at the reactant side, which shows that this equation is now balanced. So the third step now is for you to calculate the oxidation number at the reactant side and at the product side. And we found that oxidation number of sodium metal, because it's in free state, is 0, whereas oxidation number of sodium ion is +1. So that is written here. Sodium metal is 0, sodium ion is +1. And for hydrogen ion, we have 2 moles of hydrogen ion. The oxidation number of 1 mole of hydrogen ion is +1. Since we have 2 moles, that will be +1 multiplied by the number of moles, which is 2. So which shows that the oxidation number of 2 moles of hydrogen ion is +2, and that is the +2 that you see here. Hydrogen gas is in free state, so the oxidation number is going to be 0. So what do? The next stage is you take away the oxidation number at the product side from the oxidation number at the reactant side. And what do you get? When you take away +1 from 0, what do you get? You get -1, which shows that 1 mole of electron is lost, because at oxidation electrons are lost. So 1 mole of electron is lost here. And for this, we have 2 moles of electron. The oxidation number at the reactant side is +2, while the oxidation number at the product side is 0. What do? You take away the oxidation number at the product side away from the oxidation number at the reactant side. So when you take away 2 from +2, what do you get? +2. So this shows that 2 moles of electrons were gained, because at reduction electrons are gained. So what do? Then you include that number of electrons that is lost in the equation here and the number of electrons that is gained in the equation here. When electron is lost, you post that number of moles of electron to the product side. So we have sodium form sodium ion by losing 1 mole of electron, and 2 moles of hydrogen gas liberated 2 moles of hydrogen ion, I beg your pardon, liberated 1 mole of hydrogen gas by gaining 2 moles of electrons. So what is the next stage? The next stage now is to consider we have 1 mole of electron is lost, 2 moles of electron is gained. The number of moles of electron gained and the number of moles of electron lost must be the same. So what do? You multiply using what? The appropriate coefficient. So multiply with the appropriate coefficient. Which coefficient are we going to use, class? Yes, you got it. We are going to use 2 because this is 2 and this is 1. So you multiply everything in the oxidation half by 2. So when you multiply sodium metal by 2, you get 2 moles of sodium metal. Multiply sodium ion by 2, you get 2 moles of sodium ion. Multiply the electron by 2, you get 2 moles of electrons. And you multiply everything at the reduction half by 1. So when you multiply 2 moles of hydrogen ion by 1, you get 2 moles of hydrogen ion. Multiply 2 moles of electron by 1, you get 2 moles of electron. And multiply 1 mole of hydrogen gas by 1, you get 1 mole of hydrogen gas. So now remember, one of the rules says that when the electrons appear as products and as reactants, they cancel out. So 2 moles of electron appear as products here and 2 moles of electron appear as reactants here. Therefore 2 moles of electron cancel each other. And then the last step, which is step number 6, is to add the 2 half equations. So this is the product of oxidation 2Na, I take 2Na here. The product of reduction 2H plus, I brought 2H plus here. So we have the 2 products, the 2 reactants. This is the reactant of oxidation half, this is the reactant of reduction half. Then the next thing is to bring the products. So I took the products of the oxidation, this is 2Na plus, and the products of the reduction, this is H2. And then what do? At this point, you can check, you can actually check. So we have this is 0, this is plus 1 times 2, plus 2. So at the reactant side, the oxidation, the number of charges is plus 2. Here we have plus 1 for sodium multiplied by these 2. So that is plus 2. This is 0. So plus 2 plus 0 plus 2. So the number of charges here, we have 2 positive charges at the reactant side and 2 positive charges at the product side. So that is how to balance ionic equation using half cell equation method. Here is another example. Example number 2. The chemical equation that is given to us to balance is Fe2 plus Cl2, and the 2 of them react together to form Fe3 plus and Cl minus. So what do? This is very easy, and I tell you it's very easy. This is Fe2 plus, which shows that the oxidation number of Fe, that's ion, is plus 2 at the reactant side. That's at the beginning of the reaction. And at the end of the reaction, Fe2 plus form Fe3 plus. So the oxidation number of ion at the end of the reaction is plus 3. And that shows that there is increase in oxidation number of ion from plus 2 to plus 3, which represents oxidation reaction. Each time there is increase in oxidation number of an ion or of an element in an ionic equation, that is an indication that oxidation reaction had taken place. So, and that is why Fe2 plus form Fe3 plus was posted here as oxidation reaction. So what then happened? Chlorine gas, that's Cl2, liberated or produces chloride ion, Cl minus, at the end of the reaction. So the oxidation number of chlorine gas, since it's in free state, is 0, and the oxidation number of chloride ion that is formed from chlorine gas at the end of the reaction is -1. Since 0 is greater than -1, that shows that the oxidation number of chlorine has decreases from 0 to -1, which represents reduction reaction, because reduction is decrease in oxidation number, and that is why that is posted here as reduction reaction. So chlorine gas produces chloride ion. So if you look at iron, we have 1 mole of iron, 1 mole of iron. There is nothing to balance. Everything is equal. But for chlorine, we have 2 chlorine atoms here, but only 1 chlorine is here. So what do? Put 2 in front of Cl minus, and that we balance the equation. You now have 2 chlorine atoms, I beg your pardon, here, and 2 chlorine atoms here. So 1 mole of chlorine gas produces 2 mole of chloride ion. So what is the next step? Step number 3 is to calculate the oxidation number. What is the oxidation number of ion in Fe2 plus? +2, and that of the oxidation number of ion in Fe3 plus is +3. So you write that out here. As you can see what I have done here, you can see this is how to do it. Then you move on. What is the oxidation number of chlorine gas here? 0. And what is the oxidation number of chlorine what's the oxidation number of chlorine gas? 0, because it's in free state. Whereas we have 2 moles of chloride ion, and 1 chloride ion have oxidation number of -1. So when it is 2, that will be -1 times 2, which is equal to -2. So then the next thing is step number 4. Look for the difference in oxidation number at the product and at the reactant. So this is +2 that we have here, and this is +3 that we have here. So take away this +3 from this +2, and that will give us what? -1, which shows that 1 mole of electron is lost, because at oxidation electrons are lost. So then what do here? Take away the 2 moles of take away -2, which is the oxidation number of chlorine at the product side, away from 0, which is the oxidation number of chlorine from the reactant side. What do you get? When you take away 0, take away -2 from 0, you get +2. So that shows 2 moles of electron is gained, because at reduction electrons are gained. So what do? Add those number of electrons that you got from by looking for the difference in oxidation number of those substances at the product side and at the reactant side. So for oxidation half, we have what? Fe2 plus form Fe3 plus by losing 1 mole of electron, and Cl2 produces 2 moles of Cl minus by gaining 2 moles of electron. So what do? Step number 5. Multiply the electrons by the appropriate coefficients. So 1 mole of electron is lost, 2 moles of electron is gained. So what do? You multiply everything here by this coefficient. So we multiply this. So if you multiply Fe2 plus by 2, you get 2Fe2 plus. If you multiply Fe3 plus by 2, you get 2Fe3 plus. If you multiply E minus by 2, you get 2E minus. So if you multiply Cl, you multiply the whole of this reaction by this one, which is the coefficient of electron here. So what do? You multiply everything here, Cl2 by 1, it will still remain Cl2. Multiply 2E minus by 1, it is still 2E minus. Multiply 2Cl minus by 1, it is still 2Cl minus. So what do? Remember, one of the rules says when an ion appear as product and as reactant, they cancel out. So in this case, 2 moles of electron appear as products and at this reduction side, two modes of electron appear as reactants, so they cancel each other. And then you proceed to the last stage, which is step number 5. And what do you do there? Add the two half cells together, and that will be what? 2Fe2 plus as the reactant here for oxidation, plus Cl2 as the reactant for reduction, form 2Fe3 plus as the product for oxidation, and 2Cl minus as the product for the reduction. So what do you do? This is plus 2 times 2, that's plus 4. This is 0, so plus 4 plus 0, that is plus 4 for the reactant side. But here we have plus 3 times 2, that will give us what? Plus 6. This is minus 1 times 2, that will give us minus 2. So that will be plus 6 here, plus minus 2 here, and that is going to give us plus 4. So the product side we have plus 4, that's the number of charges. Reactant side we have plus 4 as the number of charges, which shows that this equation is balanced. Here is another example. This is example number 3. I like to give you more than enough examples so that you will understand the process better. So the equation given to us this time around is Cu. What does Cu represent? Can somebody tell me? Yeah, copper. So copper reacts with nitrogen 4 oxide. Copper reacts with nitrogen 4 oxide to form copper 2 oxide and liberate nitrogen gas. So what do you do? Copper has oxidation number of 0 here because it is free state, but copper have oxidation number of plus 2 here because oxygen has been added to it. So two things will tell you that oxidation reactions are taking place here. Why? The oxidation number of copper increases from 0 to plus 2. 2, there is addition of oxygen to copper. So when oxygen is added to a substance, then we say oxidation has taken place. Or when there is increase in oxidation number of a substance, we say oxidation has taken place. So therefore, Cu form CuO is our oxidation reaction. So it is posted to the oxidation half side. Then here we have NO2. In NO2, the oxidation number of nitrogen is what class? Plus 4. I'm sure all of you can do that. But here, nitrogen gas was liberated from nitrogen 4 oxide, and because it's in free state, the oxidation number of nitrogen here in nitrogen gas is 0. So there is decrease in oxidation number of nitrogen from plus 4 to what? To 0. And another reason is because there is oxygen here which have been removed at the end of the reaction. So removal of oxygen is what? Reduction. So because of these two reasons, we now understand that NO2, which is nitrogen 4 oxide, liberated nitrogen gas, and this process is called a reduction reaction, and that's why this is posted to reduction half. So what do you do? Remember, the next step is to balance all the substance except what? Oxygen and hydrogen. So we don't have hydrogen here anyway, but we have oxygen. So we are not going to balance this oxygen, and since we have one copper, there's nothing to balance here. At this end, we have one nitrogen, and at the product side we have 2 nitrogen. What do you do? We need to balance the nitrogen to ensure that we have 2 atoms of nitrogen at the reactant and at the product, and because of that, this 2 is brought here. So when you put 2 in front of NO2, you then have 2 nitrogen, which is balanced with the 2 nitrogen gas at the product side. Now remember, in nitrogen 4 oxide, the oxidation number of nitrogen is plus 4, and now that we have 2 atoms of nitrogen, so you have plus 4 in 2 places, which is equal to plus 8. and oxidation number of nitrogen here is 0 because it's in free state. And in this case, oxidation number of copper is 0, but here oxidation number of copper increases from +2. From 0 to +2. I beg your pardon. Now that is balance. The next step is to look for the difference in oxidation number at the product side and at the reactant side. So the oxidation number of copper at the reactant side is 0, and the oxidation number of copper at the product side is +2. So take away +2 from 0. That is 0 minus +2, and that will give us what? -2, which shows that 2 moles of electrons were lost. And what happened? Take away the oxidation number of sodium at the product side, nitrogen rather, at the product side, away from 8, which is the oxidation number of nitrogen at the reactant side. That will be what? +8 minus 0, and that will give us what? +8, which shows 8 moles of electrons were gained. Remember that the number of electron gain and the number of electron loss must be equal, and to do that, when they are not equal, you multiply with the appropriate coefficients. So this is 2 moles of electron, this is 8 moles of electron. What do? Look for a number, or divide. If they are divisible, you can say, how many 2 can we get here? 1. How many 2 can we get here? 4. And then that means they are in ratio 1 to 4. And then you swap that number. And that is the reason why I brought this 4 here, because I can get 2 in 4 places in this 8. So I use that 4 to multiply all the equation here. So if you multiply Cu by 4, you get 4Cu. And if you multiply CuO by 4, you get 4CuO. And if you multiply 2E minus by 4, you get 8E minus. By the way, E minus is an abbreviation, is the symbol for representing electron in chemistry. So here, since they are in ratio 1 to 4, the number of moles of electron gain and loss than the number of moles of electron loss are in ratio 1:4. So multiply everything here by 1, you get this. Multiply everything here by 1, you get this. Multiply everything here by 1, you get this. So the number of moles of electron gain and number of moles of electron loss are now equal. Then they cancel each other, and then you balance the equation. Bring this reactant here and this reactant here. Bring this product here and bring this product here, and then the equation is balanced and you are good to go. So what have we learned in our lessons today? Today we've been able to look at how to balance simple ionic equations. We've also considered half reactions. We've also been able to break an ionic equation into half cells. And lastly, we can now differentiate between oxidation half and reduction half reactions. That will be it for today. My name is Ibukunolu Ademola, and my email address is here, so you can contact me through this email address in case you have any question. So bye for now. Thank you so much.